Hello, here's Michael Poulin. Today I am going to continue representing the pattern of distributed transactions for microservices. It's part 3 called transaction orchestration. Traditionally, software transactions run under the logic provided by transaction managers. For services, this role is known as orchestrator. However, Saga pattern proposes different solution. We will talk about that. In contrast to technical transactions that can fail due to native technology causes and principles of microservice architecture consider this, business transactions may not fail unless such option is agreed upfront. Acceptance of transaction failure depends on the requirements to data consistency in the outcome. For example, if it is a payment transaction, the data consistency must be strong and transaction must complete. If it is a financial advertisement, some transaction may fail and the data may be of eventual consistency for each local case. Business even creates special operational groups that should pick up failing transactions and manually lead them to the completion. In many business domains, when we design an automatic distributed transaction across microservices, it should complete from the first go. Our task is to come up with as much reliable transaction design as possible, despite the assumption that any participating microservice may fail individually. A failure of distributed transaction can be caused by one of or all three factors presented right now on the screen. We will focus on the last one and show how to mitigate such failures. Here are the requirements to the consistent transaction, and I hope you will read them on your own. With this knowledge, I will review two of the most popular transaction algorithms, which are also mentioned in the description of Saga pattern. The first algorithm is known as choreography. DevOps usually prefer choreography because they believe they can control all participating microservices and can manage communication between them via APIs and events. In choreography, each microservice is responsible for communicating transactions further to its neighbors. This reliably works for small transactions only within the same application. For more serious transactions, not all microservices are under the control of one team, and choreography becomes barely manageable and error-prone because of that. Choreography requires that each microservice should be aware of all others that it has to expect any communication from, like microservice 2 expects communication from microservice 1. Choreography is also assumes that the microservice has to be aware about what kind of events it has to fire or which API it has to call to propagate the transactions further. The choreography is usually a frozen interaction model. Any change in any of its participants requires revalidation and resynchronization within neighboring microservices, and that cascades to all transaction participants. Choreography becomes known as a fragile design for about last 15 years, but modern microservice developers are probably unaware of this. Microservices that are assumed to participate in the choreography should be specifically designed for it, because they have to either call certain API or issue and listen certain events, like shown here, or and they have to be aware about next microservice in the chain, because microservice has to call next API or fire certain events for transaction to go forward. Also, microservices have to be redesigned again if we have to change anything in the choreography, because we have to update the changed microservice and its communication with the neighbors. To participate in several choreographies at the same time, the microservice has to be designed and implemented to support all of these logics upfront, which can easily get into the conflicting requirements. In order to add any new microservice into choreography chain, it is necessary to modify to-be neighbors, to-be neighboring microservices with appropriate communication model. If a microservice has to be removed, the neighboring microservices have to rebalance their communication. Moreover, if a microservice in the chain fails, for example, microservice 2 fails in the API chain, the entire chain crashes, because propagation of transactions logic depends on each participant and there is no mechanism to work around broken microservice. The same happens if you use push events or if you use pull events. The failed microservice breaks the chain, and the rest of the chain does not know what to do next moment. It is a terrible design practice that is far away from the transaction requirements. You can compare this situation with the requirements listed on the screen. Probably you have noticed already that Saga is a choreography. Though it uses local transactions and event-based microservices interactions locally, it couples interacting microservices by design, because all of them have to know about their neighbors. It cannot mitigate the microservice failures and can create an elusive development convenience like working with single isolated microservice, because that creates more problem than solutions for transactions. Also, as we talked about in the part 2, assumed compensating transactions for Saga pattern doesn't work. In the total contrast, a managed or orchestrated transaction occurs when there is an additional element which controls and commands the transaction, and this kind of transaction overruns all obstacles of choreography. The transaction orchestrator owns the business transaction logic and manages the invocation of microservices with no adaptation to transaction, no changes to the microservices. When the orchestrator is implemented as a microservice, its only functionality is the invocation logic to be realized. The orchestrator is also responsible for resolving any failures or in supplemental microservices using, for example, SIB or tandem pattern as shown in the diagram. Here it is. The manager microservice 0 might try to work with microservice 3, but it fails. In this case, manager immediately invokes the microservice 3/tween, and this is a SIB pattern. That's why the transaction managed by microservice 0 will continue. The master, the manager, the orchestrator also applies control rollback processes where needed, and can upload updated execution logic at runtime and report the transaction completion. It is the master of the game, and the only task we have is to make it unbreakable via distribution, resilience, replication, clustering, and so on. Yes, since independent self-contained microservices have to operate according to certain external logic, transaction logic, they must be managed as is, with no changes at all, with what they have been designed to do initially. We can add and remove any orchestrator at any time with no impact on working microservices. We can have as many orchestrators as needed, and this is limited only by the number of concurrent requests to the supplemental microservices. Of course, we assume that the supplemental microservices provide consistent outcome when invoked. An orchestration transaction, as any process, has a state. That is, an orchestrator is a stateful service. At each step, the orchestrator should be sure that the needed data has been received and temporarily persisted, or all requested actions have to be successfully performed by supplemental microservices. In the case of a failure, the step has to be repeated, but maybe with different supplemental microservices until succeeded. If participating microservices changes its interaction interface or functionality or outcomes, it is not always necessary to modify the orchestrator. It can discard changed microservice and engage another microservice that meets the transaction requirements, and this is the major power of SOA. In the following parts of this pattern, I will offer a solution that eliminates the single point of failure for the orchestrator and uses supplemental microservices in the most robust way. This is the end of the presentation, but I also would like to show you at the end a historic fact where choreography implemented in the real world and terribly failed. In 2005, Hurricane Katrina hit the state of Louisiana in the United States and caused more destructions and people death rates than it might be, because the emergency system realized that time in this state was a choreography-based model, as it was found later in the analysis. Actually, several enterprises that had to participate in the emergency coordinated actions were distracted at the first moment by the hurricane, by the flood, and could not propagate emergency actions to other enterprises that still could be evacuated but did not move without agreed communication from the failed ones. The evacuation transaction started only when the centralized orchestrated military management was deployed in that area. Thank you, that's all, and have a good day.